Howdy, we are looking at windy, and it is rather interesting. There is two very strong low pressure systems and a high pressure system over the Atlantic near the Azores. And if this low pressure system, which is now in the Baltic Sea, would be in a lower latitude, it would be probably be a very strong hurricane or something like this. And what I find very interesting about this configuration here is that it's now the shortest time or daylight time of the year, and still we have very strong weather phenomena, which makes one think that how will it develop as we go into springtime when there is more energy from the sun coming. And I think we are in for a ride. But first we have to get through the winter still. That's the satellite imagery. And I find this very interesting because there's a rather big area where we don't have any clouds or whatsoever. And I hope it is still visible. No, it's not. There has been one lightning strike somewhere here. Yeah, it's a pity that it's not visible anymore. But anyway, it has been somewhere here. One lone lightning strike. So I went over to the National Data Buoy Center, which is a rather good place if you want to check out some bathymetric maps. It's a bit sketchy to use. But anyway, we have the Tagus Basin here, and here is the southern edge of Portugal. And I think the lightning strike has been somewhere here. At the Goring Ridge. We have the Gettysburg Seamount and the Ormonde Seamount. Whatever languages there are, how to pronounce them correctly. There's also this Hirondelle too. So, Goring Ridge. And hopefully you are aware of my mountain wallpaper. I don't expect you to have read it or something, but there are like theories about Earth's electrical circuitry, the Joule antennas, like mountains or volcanoes, which are functioning basically as antennas. Not only because there is some lava flowing through the mountains if it's a volcano, but there could be also just water flowing through the mountain, and it would function as an antenna too. Furthermore, charge accumulates on peaks and edges. The Goring Ridge is a seamount in the Atlantic Ocean. It is located about 130 miles west of Portugal, between the Azores and the Strait of Gibraltar, along the Azores-Gibraltar Fault Zone. It is about 60 kilometers wide and 180 kilometers long in the northeast direction. It is, since 2015, a marine protected area of Portugal included in the Natura 2000 program. If measured from the bottom of the Tagus Abyssal Plain, the ridge would measure more than 5,000 meters in height, which would make it Portugal's highest mountain. Yeah, it would be probably higher than any mountain in the Alps. This is how it looks. And I think it looks rather interesting. Gettysburg looks very interesting. Might be a fulgurite. An electric volcano. Not only are electric volcanoes made electrically, but they also function still in the electrical environment. Also interesting, at least I found, was that the Goring Bank was eventually renamed Goring Ridge, owing to its extensive length and the determination that is the result of two tectonic plates which are sliding into and past each other. The plate boundaries here are converging at 4 millimeters a year, as well as sliding past each other. Upper mantle and oceanic crust are exposed along this ridge. Yeah, I hope that you know also that I don't really believe in this plate tectonic theory. Ferrogabro is a rock form which contains iron, which could be a clue for the electrical formation of the mountain in the first place, dated at 77 million years ago, or billions, or whatever, at least a very long time ago, as it is usually used in geological explanations. It just took so long time, which might be wrong. Also, at 66 million years ago, the Canary hotspot mantle plume passed by and caused alkaline magma to intrude. Yeah, the hotspot passed by. Where there is a crust, it is very thin, so that the moho comes up to the seafloor. Yeah, where we have a thin or a very shallow moho, there we find the volcanoes. And the moho is very deep in Finland. So there are no volcanoes, nor there is any noteworthy geothermal potential here. They are drilling the world's deepest hole for geothermal energy in Helsinki. So there is not really a geothermal potential in Finland anywhere at the moment. Sediment overlies the mantle. So this could be considered as crust. Since the Miocene era, there has been shortening of the ocean crust absorbed by folding and thrusting. Yeah, and here at the end is also still interesting. The sea mound is composed of gabbros, of the oceanic crust, serpentinized rocks, and alkaline basalts. The green stones I found, they are serpentinites. They are very alkaline. And I found them here in Finland, where we don't have any volcanoes. Yeah, that's an interesting thing to think about. But now let me show you still just one interesting thing. I don't know how interesting that was, but anyway, I found it interesting. There could be so much to be talked about this one topic here, but let's go still to another topic which I found interesting. Maybe some have seen the video I made about these very amazing clouds which have been here some time ago. This is a little bit an overview because I thought also the sky up here is very interesting because we have these ripples. And here this very bright light phenomena. It was very hard to capture this. It didn't really pick up the colors because I think it was just too bright. And also in this cloud here in the front we have this kind of repetitive pattern. And we even got the dragon, or the dragon's head, drawn into the sky. And still a bit later it looked like that. And you just have to imagine that these colors were much more powerful than they are visible here in this picture. I think with a better camera I could have made much better pictures than these. But anyway, let's go over to life science. Extremely rare rainbow clouds light up Arctic skies for 3 days in a row. Yeah, extremely rare, and then we have it for 3 days in a row. In and around the Arctic Circle, stunning multicolored clouds have been shining in the sky for days on end. It is very unusual to see so many of these vibrant clouds over such a long period. Yeah, look at this picture. That's amazing. Iridescent rainbow-colored clouds known as polar stratosphere clouds have been spotted across the Arctic for days on end. Spectacular rainbow clouds have been shimmering in the skies and around the Arctic for more than 3 days, thanks to an unusual cold snap in the upper atmosphere. Have you seen, I think it was the movie Today After Tomorrow? Where in the beginning they are flying with those helicopters and they just freeze and drop from the sky. Yeah, this is when the atmosphere isn't really working anymore. It's going to be very cold, very, very quickly. And there's some further evidence for events like this really can happen. We could probably look at the mammoths in Siberia, which got instantly frozen by probably a similar event last described in the Hollywood movie. And even more of these technicolor treats could appear during the next few months, experts say. Yeah, first they're surprised, and now they're telling me or us what is going to happen. Anyway, the colorful clouds, known as polar stratospheric clouds, PSCs, were spotted floating high in the sky above parts of Norway, Sweden, Finland, and Alaska. And even as far south as Scotland. They began to emerge on December 18th and continued to appear clearly until December 20th. According to spaceweather.com, some smaller, less distinct clouds were also spotted on December 21st, but in general they seem to be disappearing. Photographer Ramonier Sabailaite captured staggering photos of the rare phenomena above Gran in southern Norway. Her photos revealed the rainbow hues in PSCs and their iridescent shimmer that has inspired the nickname nacreous clouds due to their similarity with nacre, an iridescent material also known as mother of pearl that is found in the shells of some mollusks. The colors are spectacular, Saapalaite told spaceweather.com. The clouds were visible in the sky all day. But the colors really exploded just before sunset. The PCEs were caused by a prolonged period of unusually cold temperatures in the sky, according to spaceweather.com. That's amazing. Yeah, the rainbow serpent. PCs are made from tiny ice crystals that refract or scatter sunlight. This separates the light into individual wavelengths or colors and creates the rainbow-like effect we see from the ground. There are two types of PSCs. Type 1, made from a mix of ice crystals and nitric acid, which produces less spectacular colors and are linked to the formation of ozone holes. And type 2, which are composed of pure ice crystals and produce more vivid colors. The clouds that recently formed over the Arctic were type 2. Yeah, a better camera obviously got used in making these pictures. The shimmering structures only form in the lower stratosphere between 9.3 and 50.5 miles, 15 to 25 kilometers. An average passenger airplane flies about 12 kilometers at highest above Earth's surface. Normally, clouds do not form this high up in the atmosphere because it's too dry. But in extremely low temperatures, below minus 121 degrees Fahrenheit, minus 85 degrees Celsius, widely spaced water molecules begin to coalesce into tiny crystals that further aggregate into clouds. Stratospheric temperatures in the Arctic rarely drop below the threshold needed for PCS to form, so they are normally only spotted a handful of times every year during the winter months. The extreme cold snap that led to the recent appearance of PSCs may have been triggered in part by the current El Nino event, which can impact temperatures around the poles. However, human-caused climate change could also be to blame. Yeah, I bet not. Really not. Experts say that there is a high chance that we will see more PSCs in the Arctic over the next few months. Yeah. A very rare weather occurrence just happened 3 days in a row. Very high clouds. That's amazing. Yeah. You know, there's something big going on. This is just one sign of that. I could talk so long about the weather which is going on in Europe and stuff like that. About the oceanic currents I have been looking at a little bit. About the Gulf Stream and stuff like that. It's all very interesting. But anyway, already 17 minutes went by and I didn't get anywhere. Or at least that feels like this for me. Yes, what amazing clouds. Maybe we have to get used to see stuff like this in the heavens. Anyway, thank you. Bye.